So right up there with the color book and some of the more iconic aspects of soil science, collecting bulk density information by the paraffin wax clod and the displacement of water using Archimedes' principles, really like, classic soil science 101. Using very basic lab equipment, some paraffin wax and a bath, some string, and a scale and a couple little beakers of water, we can start to understand, we can calculate the volume of this solid and then weigh it and get its mass and calculate bulk density. Really classic lab technique. Works really well for agricultural soils that are aggregated, that don't have a lot of rocks and other coarse fragments generally. We're going to show you a technique later on in a week or two with another film about using compliant cavity and a hammer core. So being able to collect a sample, measure the volume of the hole, and then weigh it. But tonight we're going to be working on using a string and some wax to make little soil clods. It's literally one of my favorite things to do in the world. Just break aggregates open and look it up.
Mm-hmm.
So fun. So I'll be like, I didn't know I was ASMR before, but now I know. Like, I'm ASMR. Right? Okay. So, all right. So what are we trying to do? We're trying to estimate the volume of this irregular solid, right? It would be hard to measure the dimensions of this in enough ways to be able to calculate its volume through some geometric formula. Instead, we want to be able to use Archimedes' principle, which basically says that a body will displace the same volume of water that it has when it's submersed, right? And the whole lore is that Archimedes figured that out by laying in his bathtub and seeing the level of water rise, and he realized about this kind of like physical principle. So what did we do? We ended up taking this aggregate, wrapping it up with some string like this, dunking it into the paraffin wax, just some, paraffin household wax that we had here, that, standard procedure there, and coating this material with something that's hydrophobic, right? Something that doesn't like water, that would exclude the water from the going and penetrating into the aggregate. Before we did that, we weighed the aggregate, right? We need to know the starting mass so then we can relate the mass to the volume, right? Which is essentially bulk density. So we did that. We went in, we got all these, and we dunked them in water. Now, this is one of the coolest things about this lab that's so fundamental that it's even taken me a number of years to figure it out, to think about it, and really get it locked in, teaching it multiple times. So don't worry. It's almost like magic, okay? So we took a beaker of water and put it on our scale, right? And then we tared it, we put it to 0. Now, what's going to happen? Every cubic centimeter of volume that this sample displaces is going to raise the water level up. It's going to displace the water up. That elevation of water will be weighed as grams per centimeter cubed relationship between water, the transitive properties of water. So when I dunk this in, the scale's going to go up, not because it's touching the scale, but because it's making the water level rise and actually weighing that extra elevation of water. Okay, so let's check it out. So that aggregate plus a little bit of wax, it's a little bit elevated in its volume, was 18.3 grams, which was displacing water, which means it's 18.3 milliliters or 18.3 cubic centimeters. So now I think we can go up to the board and we can just quickly go over this sequence of numbers and show you the variation in bulk density from the top of the profile to the bottom. All right. So now we've gone and done our measurements on the aggregates, their displacement, and now we're going to walk you quickly through the calculation that's on the sheet that we attached, that we posted to the chat in the thing. So the information you collected over there was we'll give you the mass of the sample, we weighed it, the aggregate, the weight of the aggregate plus the coating, the displacement in water, and everything else you should be able to calculate through here. So this table for calculating paraffin wax coated bulk density, you need number 1, which is the oven dried weight. So what was the aggregate when you started? Number 2 is soil weight plus the clod. So after you weighed the aggregate, we dipped it in the paraffin, then we weigh it again because we want to know how much of the coating, the wax coating, went onto that aggregate and changed both the volume and its weight. Number 3, we'll calculate the weight of the coating, right, which will be line 2 minus line 1. Pretty simple. Number 4, we're given the density of the wax. The wax is 0.95 grams per centimeter cube. Quick side thought, right? If the density of water is 1, is this lighter or heavier than water? If you had a small ball of wax that was dried, would it float on top of the water? It should, right? Because its density is less than water, so it should float. Number 5 is calculating the volume of the coating, which is line 3 divided by line 4. Okay, so you calculated the amount that you thought you had on there, you calculate the density, and that allows you to back out the volume. So now let's move over to this other board real quick. So here we go to the other board. So number 6 here, it says on the paper, it says soil weight, coated clod and water. This is really that displacement weight that you calculated when you had the tared beaker with the water on it, and you put the clod in and it displaced the water. So that would be that grams weight that you got on the scale. Number 7, volume of soil plus coating, right? So number 7 and number 6 should be equal, right? This is weighing grams, but it's displacing water, which is 1 gram per 1 milliliter per 1 centimeter cube, transitive property of water. So these two are equal by a simple dimensional analysis. Number 8, volume of soil. Line 7 plus line 3 from over there minus line 5, right? That's going to give you the volume of soil, having discounted the volume of the coating. Number 9, now you'll be able to calculate bulk density. You have your initial mass from line 1, and you'll divide that by the soil volume, and that should give you a number in grams per centimeter cube, likely somewhere between 1.2 and 1.4. Those are the range that we really see for most agricultural soils. Much lighter than that, it's either organic or some volcanic material we'll talk about later. And denser than 1.8, you're starting to get to the point that it might be hard for roots to penetrate or cause some other problems with that soil. And we could talk about that more later. Now, number 10, the last one. It's really neat because by knowing the particle density or assuming that the particle density is the same as quartz, 2.65, you should be able to calculate the percent porosity from that. We'll work on this one as a group after we watch the video.